So good morning, and thanks for being here at 9 a.m. This is my first XLDB conference, so thanks for having me, and hope to come back in the future. I work for a company called MongoDB, and I'm not here to sell anything. So, in fact, our product is free, so use it if you like it. Let me know if there's something that you want to talk about in depth afterwards. So the concept of schema on read, I think, is actually pretty interesting. And I guess my trajectory of databases over almost 20 years now started with using relational databases as a data warehouse and sort of twisting and turning traditional transaction-oriented system into something that was really optimized for analytics. And I've gone through several different companies, and MongoDB is really the first database technology I've worked with in depth that was really focused on operational workloads. And I think the schema and read concept is something we talk about typically in the context of analytics. And very large stores of data that are semi-structured or unstructured. But what I want to talk a little bit about is the operational side of that equation, and what I think are some of the interesting things about MongoDB. So I came to just to sort of give a little context. The way I think about schema on read is there's two high-level strategies you could approach. The first is to sort of take the inverted index approach, which is to say index everything. And this is what Google did with the internet originally. Google is much more than that now, but just sort of giving you a way to query a completely undefined structure in an ad hoc fashion. You essentially, with this model, have one query type, right? Does it contain this word or phrase or whatever you can assess with the inverted index? But you're able to achieve low latency and very high concurrency with this sort of an approach. And that's sort of the trade-offs that you make. Another approach is the Hadoop approach, right? Which is to basically index nothing. And your query could be anything under the sun, but every query you have to write an actual program to run your query. The system is relatively high latency compared to something like Lucene, and relatively low concurrency. But the trade-off you get there is you're able to sort of do anything under the sun with any sort of data you can throw into this file system. And I think MongoDB is somewhere in between this, and I want to try and flesh this out a little bit in the talk today. But again, the thing that's a little bit different compared to Hadoop and compared to Lucene is it's really designed for operational workloads, where you have high concurrency, mixed read and write workloads, and very, very low latency. So I came to MongoDB as a massive skeptic, if not the least because of its silly name. But it's kind of unbelievably popular. And I have to sort of step back and wonder why that is. Today, there are approximately 30,000 downloads of MongoDB every day. Which is just kind of mind-boggling to me because it's not Napster or some product like that. It's a database. And unlike something like Node.js or Docker, which has incredible download numbers, people don't tend to, people don't think of their database as an ephemeral thing. It's sort of they stand it up and they use it for a while. So these numbers to me are very surprising, and they're very diverse workloads. I mean, this is the XLDB conference, so I wanted to point at a couple things. You see, everything from key value workloads with, very simplistic operations, but very, very high throughput and potentially large numbers of servers, across to very complicated queries with, smaller amounts of throughput, but still tens of thousands of ops per sec. And pretty big in terms of cluster scale. So we have customers with well over 1,000 servers. Once we started working with folks in China, just the numbers in China are staggering. Also, in terms of just the scale of throughput and the scale of data, it's pretty big, especially in terms of an operational system, in my opinion. So there are lots of indicators that suggest people really like this thing. And this is sort of an interesting one that looks at all types of database technology. It's an index of everything from searches on Google to LinkedIn profiles to job listings to Stack Overflow postings. And sort of is an early indicator in my mind of adoption or popularity of a technology. And so it's no surprise that if you look at things like that, Oracle's at the top, MySQL is essentially right up there, and SQL Server is third, but MongoDB, a technology that's relatively young, is just ahead of Postgres. And looking a little bit more closely at the sort of Postgres, MongoDB, which are two open source database technologies that are rather popular these days. This is a data point from Stack Overflow. So Stack Overflow, people ask questions, people answer each other's questions and help each other out. And the indicators here, can't quite make out the colors. Postgres is sort of the third one in that green. It's relatively flat. And MongoDB is the green here. And the scales are misleading. The actual numbers are essentially the same. The volume of people on Stack Overflow for Postgres and MongoDB is approximately equal and growing at approximately the same rate. But what is very interesting is that Postgres has been around a really long time as sort of, in my opinion, the best schema on write technology out there. And MongoDB is, very quickly, has become equally popular as a schema on read sort of technology. And I think that's pretty interesting. So what is driving this adoption? Why are people so enamored with this different kind of technology, different kind of database? Because there is no SQL. There is no third normal form. There is no JDBC, ODBC. It's a completely different way of thinking about and using a database. And so if you want to start using it, you have to be willing to accept all of that friction to learn something new. So that people are willing to do that, I think, is pretty interesting. So to me, when we ask people, what is it that you like, you talk to developers. And so this is something I thought would maybe be interesting in this context is when I think about an event like this, or more of an academic context, we think more in terms of theory or concepts, and less about the actual experience of using a technology. And I think one of the lessons of the MongoDB story is that experience matters, even for a database. And the user that you could potentially really focus on and rethink what a database is the developer, who is overwhelmingly the person who's going to, today, choose the technology that's going to be used for a particular project. And if you can think about the experience from that user's perspective, you might come up with a pretty different sort of database technology. So, and schema on read ends up being a very appealing attribute for a developer in terms of a database. So here is what they told us. When I use a relational database, and the way I've been building apps for 20 years, or maybe 10 years is more appropriate, is I don't write SQL, I use an ORM layer. And the ORM helps me not have to think about third normal form and this massive set of tables that I have to use to build an application. So I'm writing my code and thinking about data in one way, and the way I'm managing code in my objects in an object-oriented language is entirely different from the way the database manages the data. I'm using an XML configuration to map the way I think about data to the way the ORM layer thinks about data. And then there's still a DB schema that I have to think about because chances are my ORM layer isn't very good at writing queries. And if I want something to scale, I have to go back and tune it and tweak it. And when I do this same approach with MongoDB, everything is simplified. I just have my code, and the way the database manages data looks just like the objects in my programming language. And that is a huge relief in terms of cognitive overhead. It lets me iterate more quickly in my applications. It lets me spend less time thinking about and predicting the future, and lets me more quickly start to just build and iterate, which is much more aligned with the way people build applications today, right? Which is, I'm not building something and releasing it 18 months from now. I'm building something and releasing it 2 weeks from now. And if you have this massive cognitive overload or overhead in terms of modeling your data and slowly changing your schema, it makes it hard to meet that release cadence. So the first thing I think that is so appealing about this approach of schema on read is the data model. And just to give you some sense of terminology, we still have the concept of database, but instead of table, you have something called a collection, because the data is not symmetrical and rectangular. The data varies from record to record. You still have indexes, you still have traditional B-tree indexes, but instead of rows, you have something called a document. And instead of having joins, you have the concept of embedding and linking. And it turns out that if you can use a document model, the need for joins goes significantly down, which is also a really nice thing to not have to think too much about. So what does a document look like? Well, in the MongoDB world, it's BSON, which is a binary serialization of JSON with some extra data types. So it looks like this. So you have fields that are sort of key value pairs, and each value is strongly typed. But one of the native types is array. And if you've ever tried to really use arrays in a relational database, it can be pretty unwieldy. Whereas it's sort of a first-class citizen in MongoDB. If you want to index an array, that's fine, including an array of subdocuments. So this is an example of a particular individual who has multiple cars in their car collection, and I could build a B-tree index on any one of those attributes that describes each car in the collection. Now, what's nice about this as well is that in a given collection, the records can vary from document to document. And that's because instead of having a set of system tables, a data catalog, you have the records that are self-describing, right? So you don't go to the database and say, before you load any data, here is what my data looks like, this is what the shapes will be, and this is what the relationships will be. You literally load data. You don't even declare a collection up front. The first document you put in a collection, the collection is created and the documents start to flow. And there's nothing to say that any two documents in a collection have to be the same. So that's a really nice feature when you don't know exactly what your data is going to look like, and when you want to change it over time, you don't have to go back and change all the data that's already there because the schema is inferred at read. The second thing I think that's really driven this adoption has become so appealing to folks is the notion of idiomatic drivers and frameworks. So in a traditional relational database, I'm going to give you SQL and an ODBC driver. But I think, back to what users told us that they like, they don't really want to be writing SQL. And working with ODBC is very low level and sort of painful and tedious. When you use any one of these languages, and we support 10, sort of all the popular languages, the feeling of using the database is very natural in the language that you're already using and working with. So in Java, things may come back, for example, as a map. In JavaScript as objects, and in Python as dictionaries. And all of that happens without you really knowing that much about MongoDB. And if you're a company that has standardized on multiple languages, which is almost every case today, you're not just using Java, you're not a Java shop, you're also Python and you're .NET, then you're able to count on the same sort of capabilities and experience of the database, even though it feels like it was made just for the language that you're working in. So I think that's the second thing that's really important is that approach to drivers, back to the experience of the developer using the database. And the third thing I think is that, frankly, it's just easy and fun. I mean, when is the last time you talked to someone who said they were having fun using their database? It's just like, that's not what people say. So it's easy to acquire because it's open source. It's easy to install and configure. It's literally just a couple of minutes. Without reading any documentation, you can be up and running. It's also pretty easy to get high performance and high availability. Those things are built into the system, and without knowing any black magic of tuning, and without really thinking through complex deployment architectures, you can get to pretty robust, high performance deployments without a whole lot of effort. And then finally, back to that experience of putting the data in, there is no DDL, there's no complex data modeling exercise up front. You just sort of get going. But all of that is aligned with this concept of schema on read. And I think that begs the question of, are you not just kicking the can down the road? Are you not just adding a tax that you're going to have to pay at some point in the future? What about data governance and referential integrity? And what about analytics on the data? You're essentially, with a schema on read approach, you're saying that those are things that you're going to, consider as afterthoughts and focus purely on getting the data for the operational application up and running. And that's frequently what you hear from DBAs and from architects, the people who sort of have to look after the system long term, is what about these big questions that I need to understand? And so there are some interesting topics here that I thought it would be good to discuss, and I'll try and go so there's time for questions at the end. The first thing is, until pretty recently in MongoDB, there was no constraint enforced by the database, with the exception of a unique index. Nothing. So if your developer is merrily coding away and they have a typo in their field name, the database happily accommodates that, and you start to have corrupt data in your database. And you basically assume that all of your development teams are aligned and communicating and following the rules and a whole bunch of things that are probably never going to be true. So we added a capability recently called document validation. And the idea is, could I give you some amount of data governance in the database without giving up all of that nice flexibility that makes people really enjoy using the system? So this concept of document validation has, I think, a pretty interesting approach. First of all, it uses the query language to define the constraints. And we didn't invent a separate language for schema the way that you do in that other technologies have in the past. We basically took the language people already know and are using that to express these constraints. You can choose whether you want the validator to throw an error and reject an update or an insert, or simply return a warning. And it'll be more clear why that's a very nice thing, choice to be able to make. And then the third thing, and probably the most important thing, is you can use as little or as much of this as you want. You can validate rigorously every single field and data type and even value, or none at all, or anywhere in between. And here's an example. I have added a validator to my collection for contacts that basically says, when I add a contact into my database, I want to make sure that they were born before 1994, and I either have a phone number or an email. I could put whatever else I want in that document to describe that contact, but I want to make sure those basic needs are met by the application. And so if I go to insert a new contact who meets the email criteria but was born after 1994, I get a validation error that says, hey, I can't insert this record because it doesn't meet those validation rules. Now, there are a lot of different things you can do here. Existence of data types, non-existence, inequality, regular expressions. Probably the funnest one here is geospatial constraints. So it has to be within a polygon, it has to fall along some line. All of those kinds of things can be part of the validation rules that are built in to the collection. And if you wanted to, for example, say, well, what that's in the database already doesn't meet my rules, you can just take that expression and wrap it in a knot, and the database will return everything that is already in the database that fails your rule. So comparing this to what you might do with a relational database, it's nice in that you have a familiar language to express things. You don't have to resort to writing stored procedures for some of the more complicated things. It's very flexible in that you can apply as little or as much as you like. It's also practical in terms of applying to a production system. So if you wanted to add validation to a production relational system, it's hard for me to imagine how you might do that without taking the system offline or reloading all of the data. Whereas here, I could start to incorporate stricter and stricter rules over time with no impact to the production system and without taking anything offline or reloading any of the data. And that's because I have this really nice ability to, for example, say, what is the validation level between off, moderate, and strict, and how do I want the validation to be handled? I can either warn you and just give you an error that something is happening, and then you can deal with the data separately. You could go back and flag it and come offline and sort of continue to refine and improve the quality over time. Or I can throw an error and not let you insert or update data that's going to break the rule. I also can let you choose between, do I want to apply these rules only on adding new data or on adding and updating existing data? Because what you really might want is to, over time, evolve your schema to add more constraints, but keep existing data in the system and have them coexist. And over time decide separately, how do I want to take the existing data that I have and elevate it to the level of quality of my new data? And it's just a really, I think when you're dealing at the scale of hundreds of terabytes, you have to assume that data is going to exist in mixed schema versions. And being able to accommodate that sort of gracefully and without a whole lot of pain, I think is a nice thing. So you can also use this to do versioning of the schemas. You can flag your data with different version numbers and make that part of the validation logic as well. So The next thing I think that's interesting to talk about in this world of schema on read in an operational system is what, for lack of a better word, is Schema Discovery, which sounds like a news show on the Sci-Fi Channel. So we had this, we went to one of our customer meetings, customer advisory board meetings, a bunch of folks from people who've been using MongoDB and know all the pains and warts and are constantly prodding us to make the product better. And we said, hey, we have this new tool that we've been working on that helps you visualize the data that's in your system. So if you have a schema on read system and you don't have any constraints, what on earth is in your database? If I'm a DBA and a development team hands me a new application, how do I have any idea what the data is? And I can't query the system tables. And I could, am I going to do a table scan and look at every single record? So it's a non-trivial problem. So this is a tool that basically samples the data and visualizes the distribution of fields, the data types of the fields, and the values of the fields. So it's not something like Tableau. It's designed for a DBA to really kind of dig in and get a sense for what is the actual data. And when we showed this to folks, one of the DBAs who's responsible for managing 50 apps at one of these customers said, you guys, we hadn't figured out a name for it yet. And he said, you guys should call this what the hell, as in what the hell is in my database? Because this was the problem that he lived with every day, was not knowing and not being able to easily see what was in the database. So on the left, you have a list of collections. Ooh, I can use my 2 Omega. This is a comprehensive list of all fields. The fields aren't necessarily in all documents, so you get to see when you hover over each of these, it tells you the distribution, what percentage of documents have the fields. And then if you look for some fields, it might be that the data type is not the same in all documents. So you also get a visualization of the data types in the fields. Then we actually also visualize the different values themselves. So depending on whether it's a string or a date or an integer, we visualize things in different ways. And then on the far right, you can actually look at individual documents. And these are all interactive, so I could click on each of these values and it would filter things down and do a new sample and allow you to kind of put the data on a potter's wheel and get a sense for what it is that you're working with. Now, this ends up being a pretty handy tool to use that's been really, really well received by folks because I think one of the intractable problems about schema on read is just not knowing exactly what you have to work with. So what do we have in this space of schema on read for an operational database? What are some of the things we have to think about in the future? So schema evolution is a big topic. As I said before, we have to assume there's a mix of data at different stages of evolution and that schema will evolve over time. So how do we allow you to associate validation, to understand what the data is, and to help you evolve the data gracefully in the system without bolting on some ETL tool on the side and trying to reconcile data between different systems, et cetera, et cetera. Another is the concept of specialized storage engines. So MySQL is architected in such a way that you can plug in different storage engines. And MongoDB is similar. And it was a pretty important evolution of the product a couple of years ago. But it allows us to basically present one query language, one security model, integrations, tooling across the database, but to then use different storage technologies depending on the use case you have at hand. So there are some things that are there today, but future things are things like Worm, or even potentially blockchain, proprietary hardware from specialized vendors where you have APIs that bypass the file system. And there's no reason why we couldn't, for the transactional side of a deployment, have things in a B-tree storage engine and then also maintain a copy in a columnar storage engine with specialized index for analytics and have an integrated data warehouse in the system. And then finally, complex transactions. So today, MongoDB lets you coordinate transactions and provide asset properties, but just for one document at a time. But that's not it's good enough a lot of the time, but it's not good enough all the time. So we want to provide the ability to do these complex transactions across multiple documents, across a WAN, and help you make sure that those are high performance and can be a part of how you design your applications. So These are interesting, I think, pretty hard problems. And if you, we of course are hiring and have great internships. So if you have students who want to work on these kinds of things or want to work on them yourself, I would love to talk to you more about that. So the bigger picture, I think, for MongoDB is to think about how we can take this schema on read philosophy that we're doing for operational workloads, but also apply it to a wider spectrum of use cases. And that's back to this pluggable storage engine architecture that I mentioned before, where the surface area of the system is consistent across the different use cases, but you can plug in these different storage technologies and optimize for very different use cases without making the experience of using the product different. So that thing that people like about MongoDB from an experience perspective is the same, but under the covers, we're able to optimize for a lot of different things. So that's all I have. I'd be happy to take a couple of questions. I have a few minutes here if anybody has something they'd like to talk about.
I can kick us off. So, hello. Can you hear me? No.
Oh, there you go.
What? Oh, yep. Okay, so I did come of age, like many in this room, when we all start with an entity relationship diagram. Third normal form is never questioned. And so a reaction that you can imagine us having is, heresy, sir, this is heresy. But I think you make a convincing case why it's not. But I guess my question is, what do we give up? I mean, it seems like we get it all.
We do not get it all.
Okay, so what don't we get? That's my question.
Well, so for example, the lack of a predefined structure, you are accumulating a tax, I think, that you have to pay at some point. So I think one of the appeals of third normal form is you're paying up front the cost of pre-organizing the data to make it so that you can access it in a lot of different ways in a sort of predictable model. So I can conceptually be organizing the data for high throughput transactions, and I can still run reports on that data with a standard BI tool, because the BI tool looks and says, what are your tables and what are your relationships? And it's built around those assumptions, and by understanding the relationships and tables, it can automatically generate the queries. Now sure, third normal form isn't optimal for analytical workloads, but you can still do both out of that same model. And in MongoDB, if you wanted to take any BI tool and point it at the database, you're kind of screwed, because there is no first step of tell me what the schema is so I can automatically write the queries. So when we went to build a BI connector for all these tools, we actually have a widget that goes and samples the data and builds a schema, and that hands off these files to the BI tool so it knows what to expect. But if you went back and dramatically changed all the data in the system, those assumptions would be false. So I think there's certainly at least that you lose. And I think another thing that you lose is if you know the schema up front, there's a lot you can do in terms of cost optimizations for storage and for query planning. And we don't have that, right? We compress the data, so the storage cost is not that big of a deal, but the query planner isn't today able to take advantage of an understanding of the data, how it's laid out in terms of planning a query.
Okay. Anyone else? Okay, Kelly, that was an awesome talk. Thank you so
very much.
much.
Thanks for having me.
Let's thank our speaker.